with some asterisks, and I'll show off some of that stuff in the demo. Right now, 2.x is Kubernetes only. We are going to expand that in the future, but we had to start somewhere, and so it's a starting point for us. Okay, and a service mesh, hopefully you all know this by now, but a service mesh is an infrastructure layer that tries to manage the runtime communication between your different services. So there's a reliability aspect, there's a security aspect, there's a visibility and observability aspect. And I'll show off some of that stuff in the demo. So far, so good. Send all complaints to Lockie via chat. I'm going to jump straight into the demo. And Lockie bullied me earlier, and he said that I should show off some of the really experimental, really fancy stuff. And so I'm going to try and do that, but it's extremely risky. So if it doesn't work, we all know who to blame. All right, so let's get my terminal window going. Okay, so I'm going to demo not just Linkerd 2.0, but the Edge release. So we have weekly Edge releases, and if you run this command, curl-s run.linkerd.io/install Edge, you get the CLI that will bring you the latest Edge release. So really living on the edge. Okay, so let's see. I ran this command already because it takes like, a couple minutes to run, and we can add the CLI to my path. So now I have the ability to say Linkerd. And the very first thing that we're going to do, we're going to run this command called Linkerd check. Let me drag this zoom window over to the side here. Hopefully it'll be a little more out of my way. And just to set the context here, actually, even before I run this command, I have an empty Kubernetes cluster, nothing up my sleeve. Kubectl get ns. It's running on Docker for Mac Kubernetes. And wow, it's been up for 62 days, so possibly the longest lived Kubernetes cluster in the universe. And I've just been like adding and removing services to it, so that's been fun. Okay, and then we're going to do Linkerd check. Sorry, Linkerd check -check pre. And what this command does is first checks to see whether the Kubernetes cluster is like ready for Linkerd, right? Because there's all sorts of weird RBAC things that could happen. There's all sorts of different versions or whatever. So this is just the sanity check. Okay, everything's fine. We can install Linkerd on this cluster. And actually, I don't know if you are a Kubernetes expert, but you can see we created some cluster roles and cluster bindings. We have an experimental feature that I'm not going to demonstrate called --s single namespace, where rather than cluster-wide permissions, we actually just look at roles and role bindings. So if you are a user of Kubernetes, you have access to a namespace, but you don't have access to the cluster as a whole, you can use this and you can install Linkerd in the same namespace as your app. I'm not going to demo that, but we want to really make it as light and as easy to install Linkerd into a Kubernetes cluster as possible. We don't want you to have to ask permission for anyone. You should be able to just do it. Okay, so but for this for this demo, I'm going to kind of demo the opposite side, which is we're going to do a cluster-wide installation. And in fact, we're going to use admission, webhook, mutating, control-y things to automatically add new services to the Linkerd control plane. So let me actually boot up my demo app first. Okay, so before we do anything with Linkerd, right? We run the CLI. CLI says everything's fine. We are going to install this app called Emoji Voto. So I'm going to download this Kubernetes manifest from the outside world. I'm going to apply it to my Kubernetes cluster, and we can see that it creates a namespace called Emoji Voto, and it's created some things. And if we get all in that namespace, we will see. Whoopsie, what did I do? Spelled the namespace wrong. We'll see that it's got a couple pods, some services, and then it has this web service which has a cluster, an external IP. Because this is Docker for Mac plus Kubernetes, I can actually look at localhost right on my laptop. So let's close this thing. Let's check out localhost. Okay, and here is my app, right? This is good old, if you've seen Lockie's excellent Linkerd 2 unboxing video, you will have seen this. In fact, I think we demoed an early version of this app at KubeCon last year. So this app, it's been around for a while. All right, and the whole point is you can vote on emojis and you can pick your favorite one, right? And then surprise, one of these emojis, this weird squishy brown guy with a smiley face, returns an error. Okay, and for the sake of the demo, like this is intentional, right? And the reason why I like to start with this app is because this is a very common situation, right? If we look at the Kubernetes dashboard, let's actually go to the, oops, I got to refresh it in order to get to the emoji Vodo namespace. All right, so we're looking at the Kubernetes dashboard. Everything's green, right? As far as Kubernetes is concerned, everything's fine. The pods are running, the health checks are responding, right? And it's not a failing of Kubernetes, it's just what Kubernetes understands about this world is, are the health checks responding and are the pods running, and everything's fine, right? So now we're in this very common situation, which is we have an app that we know is broken, but Kubernetes doesn't know anything about that because Kubernetes doesn't know about success rates, it doesn't know about services being slow, it doesn't know about any of that stuff. Okay, so what I'm going to do now is I'm going to delete this. I'm just going to delete the namespace. Delete for emoji, and we're gonna reinstall this app in a second. The reason why I want to do that is because it basically makes the demo a little bit easier. Okay, so now let's install the Linkerd control plane. All right, so enough about emoji Vodo. Let's install the Linkerd control plane, and I'm passing in these two highly experimental, highly dangerous flags. Okay, they're not that bad. One is called TLS equals optional, which means that we are going to actually put TLS in between every single service automatically. And then this proxy auto inject flag means that we are going to use Kubernetes fancy new mutating webhook admission controllers in order to automatically inject Linkerd data plane pods next to every application. This is like the super fancy way to do it. There are less fancy ways of doing it, but like I said, Lockie kind of bullied me into showing off the good stuff. And this was a contribution from someone named Ivan Sim. It was a lot of work to get this in, and it's been really exciting to have contributions of this caliber in the project. So thank you once again, Ivan. Okay, so now we run our Linkerd check command. So we've installed the control plane, right? It's often a namespace called Linkerd. And like various things are like booting up because this is running on Docker for Mac, and meanwhile I'm using Zoom to which consumes 500 cores. But this Linkerd check command, I don't know if you noticed that, we'll just wait there and it'll retry until everything's ready. Okay, so now everything's fine. We have Linkerd check. If I run this again, it'll be instantaneous. Yep, everything's okay. So now I have the Linkerd control plane. And in fact, we can just look at the dashboard. Just look at the dashboard. Okay, so we have the control plane installed in this namespace called Linkerd by default. And what Linkerd is very good at is understanding what is the traffic and what are the success rates of all the various components. In fact, Linkerd by default also monitors itself. So we can look down in here, we can say, oh, this is everything that's in the Linkerd namespace. We can see there's Grafana and Prometheus. There's two new things, Lockie, that might be new to you. The proxy, we have this proxy injector component, and we have a CA component. So actually, Linkerd is going to be running its own CA, and it's going to be generating TLS certs. It's going to be distributing them to each of the services. So again, zero config, right? So I don't want to have to write any YAML. At some point, there might be a little bit of YAML, but right now there's no YAML. And now I'm going to install emoji Vodo again. So let's do that same thing. I'll background the dashboard. Let's do emoji Vodo, not delete the namespace, but let's install that thing here. Okay, so I'm taking that same manifest, I'm applying it again. Now I mentioned previously that there are other ways of doing this. In the demo that I normally give, emoji Vodo remains running the entire time. We install the Linkerd control plane over to the side, and then we bounce the pods, and the app remains up the entire time. That's pretty fun, but for this case, I wanted to show off the fancy auto injection. So what you'll notice here is that I haven't done anything other than apply that manifest as usual. In fact, if we go now to the Linkerd dashboard, we'll see we are automatically discovering this emoji Vodo namespace, and we're discovering that the pods have been meshed, and we're starting to see metrics for each of those things. So I have to drag zoom over to the other side. Okay, so what Linkerd has done with all this fancy magic, and once again, there is a non-magic version of this, but I want to show off the magic, is it has installed a tiny little proxy next to every pod, reasonable sidecar pod. In fact, if we look at the Kubernetes dashboard, okay, this was the old version. If I hit refresh here, what we'll see is a slightly different view, which is, yes, not only do we have that emoji voter web service, but we have a little proxy next to it. And then this thing is like an init container that sets up that does some IP tables magic so that all traffic is going through here. Okay, so going back to my Linkerd dashboard, what we'll see is immediately we have these deployments and we're starting to see success rates, right? And obviously emoji is in great shape. We have a big red frowny face next to the voting service and next to the web service. VoteBot is a little bot that's sending traffic, so it actually doesn't have any inbound traffic, so there's no success rate really to report for it. So let's take a look at the web service and let's see. Now the goal is, we know there's a problem with the app. Kubernetes says everything's fine, right? All the pods are green, health checks. So how do we actually debug this, right? And I want to give you the tools to debug this thing in a way that doesn't involve any kind of rewriting of your app or instrumenting your code or anything like that. All right, and so we're looking now at the Linkerd dashboard for the web service. And what we can see is that, here's our web service in the middle. It has this miserable success rate. It's taking traffic from VoteBot and it's sending traffic to emoji, to the emoji service and to the voting service. And obviously one of these is fine and one of them is failing. All right, so we can click on the voting service and you can see, okay, voting service is taking traffic from the web service. It has some miserable success rate. Taking about 1 request a second. That's pretty good for my old laptop, which is starting to heat up. And in this table down here, what we have is a live sampled view of all the requests that are happening to the service. And we can see that a lot of them are totally fine, but some of them, vote squishy brown face, has a 0% success rate. Okay, so we're starting to get a clue now of where the problem might be. In fact, we can click on this tap interface here, and I'm actually gonna let's stop this here. This is another tool that I really like from Linkerd. We now have, this is now tapping all requests between web and voting. So show me a sample view of all the live requests that are happening between the web service and the voting service. And we can see that there's a lot of requests, and this app is a GRPC app. For those of you who are familiar with GRPC, everything is a HTTP 200. But the GRPC status is either okay or unknown, and unknown means error. Okay, so let's actually pause. Let's stop this now. So we can see, every time that we make this call to vote squishy smiley brown face, it is an error, and all the other calls are okay. So at this point, we have now the tools that we need to go talk to the team that owns the service, or to start debugging the actual code itself, or to look at the logs, or whatever it is. We know that this one call is what's failing throughout the app. Okay, so that's the nice kind of debugging story. Again, without having to do anything to our application. We don't even know what language this stuff is written in, right? We haven't instrumented anything. There's 2 brief things I want to show off first before we go back to slides. The first is, you may have noticed that in this table, we actually have these little orange links here. Let's pick a good one here. Let's go to web. And this will take you to the pre-configured Grafana dashboards. Just a little bit slow as we load Grafana. And so we have, what we try and do is build you these pre-configured Grafana dashboards for each service, where we show you kind of the top line metrics, or the golden metrics here. So we've got one for success rate. So here's the success rate web. Here's the request rate, and here is the latency. And we can see we're recording P99, P95, and P50. And everything was looking good until I started Grafana. And then there was a spike, and now we're kind of back to, well, I wouldn't call that very good. And the other thing you'll notice here is that we have this little lock icon next to the web service. I don't know if you can see that. I can't move the mouse over it, which means that all of this traffic is being TLS'd. If this web service were taking, different bits of traffic, if it were taking, non-TLS and TLS, then we'd see those split out here. And then finally, we actually, if you scroll down and in here, we actually group your inbound and outbound traffic. Yeah, here you can see, so here's the outbound traffic that the web service is making. It's making a bunch of calls to the emoji service and a bunch of calls to the voting service. And we split out the request rate by that. And in fact, we've also split out the success rate. We try and give you these dashboards all set up by default, and want to make your life easy. And that's why, if you were wondering, in this little view of the Linkerd namespace. Here we have a little Grafana and a little Prometheus instance. And the way that works is we cap these. We put pretty tight boundaries on the amount of data, and Prometheus will start expiring data, you know, after a couple of hours. This is not meant to be a huge Prometheus install that you then have to manage because it's holding all metrics for all time. We want you to get your data out of this Prometheus and put it into a real one. And this is basically here in order to do, you know, some fancy stuff for us as part of the dashboard, and also as part of the CLI. So I haven't demoed this too much, but we can do things like, no, I need to give it, gosh, someone's gonna have to tell me how to use it. Deploy, can I say that? All right, this is what I get for deploy -web in namespace emoji photo. Can I do that? All right, good. So this is actually a, let me reduce my font a little bit. This is a CLI view. I'll reduce it more so we can see all this stuff. A CLI view of one of those tables. So you don't just have to look at the web browser. We actually want to give you a CLI view. And this is, you know, literally it's like top, you know, looking at processes, except here we're looking at calls. We're aggregating, you know, so we can see, all right, since we started top, we've made 27 calls from web to emoji and so on. And then there's another nice one called stat. That's kind of like a PS. Do I dare? Let's try. Let's actually do namespace. All right. Clearly, I am the type of person who clicks around at a web UI and doesn't run the CLI. Lockie probably knows how to run this, and you know, refer to his video for the answers. Okay, so let's go back here. Now, this is basically the end of the demo. There's a couple things I wanted to point out. The first is that you know, what I demoed here was like the full fancy version where we install a CA, we're doing TLS, we have cluster-wide access, we have a, you know, mutated webhook and mission controller. There's a much simpler, kind of easier world where you don't have any of that stuff. You just deploy into a single namespace. It's really a kind of a different focus for the product or for the project. But we want to make it really flexible. And most of all, we want to make this really fast and lightweight. So that concludes the demo portion. Survived mostly unscathed. And then let's go back to our slides. And I promise at some point, it's not just going to be me monologuing. Actually, while we do this, let me save my precious CPU for Zoom. I'll delete that thing because the bot is actually running and sending traffic. Okay, so that was a demo. So let me give you a little context about Linkerd 2.0 and why it exists. What I just demoed was 2.0. You know, Linkerd, I think you saw on the previous slide, has been around for, you know, it's been around for 3 years. Of those, you know, it's been in prod for at least 2 years. It was the original service mesh. It brought that term to the world. And we've learned a lot since going through that process, because we spent a lot of our day not just, you know, making Linkerd better, but actually trying to help companies and engineers adopt it into their architecture. And what we learned is that basically the value props of the service mesh are really great, right? There's a lot of value there. You get reliability, you get visibility, you get security, you know, and you get it all at the infrastructure layer. You don't have to get the developers to like write their own retry logic. But there are some big downsides to Linkerd 1.x and to kind of the other service meshes that follow that pattern, which is that they're big pieces of equipment, right? You've just adopted Kubernetes, which is, you know, a huge amount of machinery, and now we're asking you to adopt this other big layer of infrastructure. And if you do, well, you get all this good value out of it. But you know, it shouldn't have to be that complicated. It shouldn't feel like this big infrastructure layer. So a lot of what we've done with the 2.0 release of Linkerd is actually strip stuff out and try and make it as minimalist as possible. You know, again, so that you as a developer even could install it in a namespace and not have to go through, you know, 6 layers of architects and POCs and, you know, a 12-month service mesh roadmap. Like, you know, that stuff is okay, but it doesn't have to be this way. And we also really tried hard to make it to move it away from an all or nothing proposition. So it shouldn't have to be like you install a service mesh across everything or you get nothing. You should be able to do it incrementally. And then the final big kind of learning that we had, and I'm not going to dwell on this too much, is that everything that we built in the 1.x release, and I'll emphasize that we're continuing to maintain this, and like we've got lots of adoption, and we love our 1.x users, but the focus was really on the kind of the platform operator role, right, or the platform owner. And we felt we had this feeling that we were underserving the service owner, or the actual developer who had to use Kubernetes, and for whom the platform owner is actually building stuff, right? And I think we're all kind of on the same. We all have the same goal, which is we're not doing infrastructure for infrastructure's sake. I mean, it's fun, but like it's not. It's a means to an end, and that end is we want to have our developers and we want to have our service owners be able to do their jobs better. So a lot of what we've tried to do with 2.0 is give tools to service owners, to developers, to the people who have to use this stuff, make their lives better in a very direct way. Okay, so I said a lot of this in the previous slide. We saw a lot of these views during the demo. We saw kind of the service-centric dashboards and some of the debugging and diagnostics tools. You can actually install Linkerd on just one service, which is really cool. So if you own one service and one namespace, you can still get a lot of value out of Linkerd, even without having to ask for permission. 0 config, 60 seconds to install, at least plus Grafana health check time or whatever. And then a big focus on visibility and debugging. And then we saw some of the CLI tools. No permission required is like our implicit tagline. And then for platform engineers, the consequence of this, which I really like, that you can actually be incremental about Linkerd, right? You can run it on one service, and then you can add another one, and you can add another one. And so in one service, it's kind of silly to call it a service mesh. So we call it a service sidecar, because there's just one service, so what are you meshing? But as you add more and more services, you're kind of back into mesh world. So this should be good for platform owners as well as for service owners, because you can be incremental, you can do things slowly and safely. Alrighty, and since we have engineers on the call, I'll spend 3 seconds talking about the architecture. This is actually pretty similar to every other, almost every other service mesh that's out there. There's a control plane, which here we have like kind of expanded on the top. And there's a data plane. The data plane is pretty easy, right? You just have a bunch of proxies, and you stick it next to the application as sidecars. Linkerd 1.x, you can use it as a sidecar, you can use it as a daemon set. We had a lot of daemon set deploys, but it's just as easy to use it as a sidecar, and there are some users who do that. For 2.x, we're really focused on the sidecar use case. And the reason why we're able to do that is because these proxies now are super, super lightweight and super fast. So we've built this networking stack in Rust, which allows us, to basically have native code performance with all sorts of nice security guarantees. And like, you're not going to have a buffer overflow exploit or anything, because Rust has this very strict memory model, but there's also no garbage collector, right? So you can amortize all the memory usage across the request traffic, which means if your latencies are super spiky, your latency distribution is super sharp, which is what you want. So, the P99s for the Linkerd 2.0 proxies are like less than 1 millisecond, and it takes like under 10 megs of memory. So they're just as small as possible, which is good, because if you're deploying them as sidecars, you can have a lot of them, right? You can have one per application pod or service pod. And then we have the control plane, which is sitting off to the side. In the demo that I showed, those were the components that we were looking at, where there's a web component and there's a controller component, there's a Prometheus, there's a Grafana. In this diagram, we don't have the CA, but there was a CA component if you use that -TLS equals optional flag. And then there's the webhook component if you use the -- proxy auto inject component. You can add, you can make this like kind of fancier and fancier. But the whole control plane itself is also designed to be small enough that you can run it in a single namespace for a single service. And it's not like 500 megs, it's like 50 megs or something. I don't know. I think it was under 50 last time I looked. Okay, so think small, lightweight, and fast. Okay, so that's the end of my Linkerd demo, Linkerd 2.0 demo and monologue. We GA'd Linkerd 2.0 in just last month. We've had an excellent community of adopters and contributors. And I wanted to have, as you know, to try and make this more real and less of like a cerebral thing, I wanted to have a fireside chat with one of our earliest adopters, Ben Lambert. And there's no fire, but you can imagine like a Kubernetes cluster that's just like, you know, under heavy load, and maybe it's like getting a little warm. So Ben, thank you for joining us.
No, it's fine. It's good. It's good to be here. Hello, everyone.
So can you tell us a little bit about, so you work at a company and you work on an app called Just Football. Can you tell us a little bit about what Just Football is?
Yeah, of course. So Just Football is a startup. We are based in Stockholm, so everything's kind of pitch black outside and very cold at the minute. We started in 2016. We started with 4 people, and now we're about 15 people. So yeah, we're growing slowly but surely. We build an app basically for kids to kind of get them out of the house, stop playing the consoles, and start doing some exercise, really. So we basically try and take the concept of like FIFA or like NHL, Madden, all these console games that kids play all the time, and then try and combine that with actually playing the game in real life, and then you progress in a virtual career. So basically, like, we give you, in terms of football, like, you go to a pitch, you check in, and then we give you challenges to play. We can do like cool AR stuff and things like that.
Okay. And football in your country, football is like the round thing that you kick with your feet.
Football is totally different. This side, no, football is not
that you throw with your hand.
Football soccer over here.
Okay, got it. And your app, so your app is not only like a cool iPhone app, but it's actually helping kids get exercise.
Yeah, it's also available on Android as well, which is interesting. So yeah, we'll come on to that shortly.
And Android. Okay, excellent. Excellent. Okay, and then presumably, you know, in addition to the cool iPhone and Android apps, there is a backend component to that. What does that look like? Kind of what is the stack that you're building?
So we deploy into AWS. We have 2 AWS accounts. So we have one for prod, one for dev, which means that we then have 2 Kubernetes clusters to manage. So one for prod, one for dev. I know there's some way we've thought about basically running just one cluster and having some cool stuff with services to just do dev and live, but for now we've just got 2. We're not using EKS or anything like that. It's just all COPS for deployment. Our architecture is basically not microservice-y or not too much microservice. It's more like service oriented. So they're a bit bigger chunks, a bit more individual services that kind of give value to the product.
Medium services.
Sorry?
Medium services.
Yeah, they're medium services. They're not micro. But we kind of go by the mantra that every service that we write should be rewritable in a day. And that's kind of the size that we want to get to.
Got it. And how many of those services are you running?
So we have about 40 of them. The game is not super big, but it makes sense to slice the services to be pretty small, I guess. Okay.
And then, like, what languages and how are they communicating? And
so language-wise, we have a lot of Node and TypeScript. We also have started porting a lot of stuff over to Go. Like, we're a startup, like, we have to write stuff really fast, and kind of Node allows us to do that. Like, it's kind of a very quick bootstrap language. Like, we can get up and running pretty quickly, but then for the more stuff that we're set on and solid in, we're kind of moving a lot of that over to Go. Yeah, that's kind of it. In terms of how they communicate, everything is done internally with GRPC.
GRPC?
Yeah.
I'm sure that's a good idea.
Yeah. I mean, it's interesting. It's we basically had everything as HTTP to start off with, and then we started load testing it and realizing that there was so much overhead in the amount of connections that we create and the amount of like resources that uses. So our architecture basically starts off with a lot of microservices, but we have one public API, which is GraphQL, and GraphQL is like the API that the phone client talks to. The thing about the GraphQL client is that it talks to quite a lot of services, right? So you come into GraphQL and that might call 8, 10 different services down the stack. So if we're doing that all over HTTP, the amount of like connections that we have to open then kind of gets very exponential as you go down the stack, because they also talk to different services and so on and so forth. So yeah, we switched to gRPC. I mean, it's pretty good. Like, we kind of the thing that's really hard, especially in HTTP land, is REST APIs are very hard to design, and every developer has a different idea. So we basically end up with so many different ways to communicate, some data that the service needs in the URL, some data is in the post body, like it's very hard to manage, whereas GRPC is all kind of schemas and protobufs, so it's kind of nice.
You don't get a choice.
Yeah, I know, you gotta get with it, I guess.
Right,
yeah, it's
right. Okay, so let me see if I can summarize it. So you are using Kubernetes, you're on EC2 with KOps.
Yep.
You've got 40 services, are written in a mix of TypeScript, Node, Go, something else. You've got GraphQL as kind of the ingress layer, and then GRPC for all the communication.
Yeah, exactly that.
All right, that's a fancy stack.
It's, yeah, I mean, I wanted to build this.
Sounds like a dream.
Yeah. It's not changed in 2 years. It's been the same for 2 years. The GRPC was the only thing that changed, really. Okay. But yeah, it's been good.
Okay. And then the other, awesome component of your stack is Linkerd. Yeah. So how did you stumble into Linkerd?
So this is interesting. So I watched a talk by Oliver from Monzo about their stack, basically. So I'm from the UK originally, not from Stockholm, not a Swede. But I watched a talk that he gave about kind of his setup and like Kubernetes and moving across Kubernetes and then having Linkerd to do all the interesting stuff in the middle. So I always wanted to get started with it. We tried Linkerd 1, but like you said earlier, it's very all or nothing. And we couldn't really get it working for us. But Linkerd 2, however, it works. Super nice.
Great. Awesome. And so tell us a little bit about how you were running Linkerd in this stack. Is it in production all the time? Is it just off on the side?
Yeah. No, it's on all the time. So we initially we wanted to use it for the GraphQL side. So we want to basically know how GraphQL is treating all the dependent services. Like, can it talk to them? Is it working? Like you demoed earlier, it's very hard to know when a service is performing well just by health checks, right? Like we ship a lot of stuff to live every day. Like we want to know if something breaks quicker than just a health check. Like we want to be able to see it in real time. So initially we just use it for GraphQL, but like anything new that we're building now has Linkerd sidecar coupled in next to it so that we can track and monitor that service when it comes from new into, further down the line over time with real live traffic. Like it's very hard also for us to get an idea about what services talk to what. Like when you're moving fast and building stuff and shipping stuff, like no one really has any idea about what services talk to what at a very high level. Whereas Linkerd gives you that network graph, basically, the topology.
Yeah, it's crazy that is such a common problem, but even back when I worked at Linkerd, this was like 6 years ago, it was impossible to keep track of who who was talking to whom.
Yeah,
we'd have people come by and like they'd make a spreadsheet. And like after 2 weeks, but after an hour, like that spreadsheet would be obsolete because someone had changed.
Yeah, everyone starts out with the best intentions, but it's very hard to keep track.
Right. Yeah. Okay. And then are you looking at those Grafana dashboards? Are you using the CLI? Are you looking at the Linkerd dashboard? Like what's your day-to-day look like?
So we have both the Linkerd dashboard and the Grafana dashboard on all times, like especially for GraphQL, like that will tell us when something downstream is broken, like something that's mission critical or like that is the tier 0 service or whatever, that is used by GraphQL, and GraphQL will tell us when that service is broken by using the dashboards that Linkerd provides. Like it's very hard to it's very hard to understand when a dashboard or when something breaks when you don't see the dashboard all the time. Like if you have a rotating dashboard, you don't see something change from red to green. Like it's very hard for you to do that. But if you've got both dashboards up there all the time, you can see very clearly what the problem is.
Got it. Okay. And then final question, and I promise you get you're free of this of the webinar finally. Can you give us an instance of where Linkerd really helped you out? Tell us a story.
Yeah, so I can give two. So one is just a few weeks ago, we deployed two services concurrently that both talk to each other, or that basically had communication with each other. But they were deployed concurrently in Jenkins. So we use Jenkins for CI, so we have pipelines that run, and they can run concurrently. So we made a change at the same time. Obviously, we test everything on CI, but they were only testing with the latest version of each service, which was changing currently. And then that ended up getting all the way into production. And basically, there was a schema incompatibility well, a probe of incompatibility between the two versions. So that's very hard to test with a health check because you don't see the health checks failing because the schema's fine, like it's returning properly, but you don't see the problem. So yeah, open up Linkerd dashboard and we can find out exactly what the problem is straight away, what service is broken, like where the error is in the path, I guess. And the other one is, this is a bit embarrassing, but so we...
that means it's going to be good.
When we switched over to gRPC, we obviously we've got a lot of stuff written in Node, and the documentation for the gRPC client isn't great, like it's getting there, but we just totally forgot about timeouts. So we were calling all these services, well, not really setting a timeout for the dependent service. So I think it defaults to 30 seconds, and that's a long time when GraphQL is waiting 30 seconds for a reply to the client. So yeah, I mean, Linkerd, obviously, as soon as we put Linkerd in, we could tell what the problem was because Linkerd then changes the timeout to 10 seconds by default, and you can configure that. So that kind of helps us out a hell of a lot. And when we've got 40 services going through and updating the clients for each one of them, downstream services, kind of a big task. So this helps us out a lot.
Great. Okay, that's a great story. In the next version of Linkerd, in 2.1, which should be out before KubeCon, we're going to introduce this notion of service profiles, where you can actually, on a service by service level, you say, here's the retry behavior I want for this. Here's the timeout behavior that I want for this. Here's the like circuit breaking behavior. And you can start parameterizing things like per service. And that's going to set us up to give you even an even better level of configurability.
Perfect.
Yeah.
I think that'll be good.
Okay, Ben, well, thank you very much for joining us. I don't think you're free of webinar jail yet because Lockie is now going to do a Q&A session, and there may be questions for you. We'll see. We'll see who has said the craziest things.
All right. This is my favorite part. I actually really like the kind of fireside format. So kudos to putting that together, and hearing from production users is always fantastic. So we've had an inundation of questions. There are 18 in the queue. I'm going to try and summarize some that are similar, and I'll give you the opportunity to answer them, but just keep in mind, I will try and get through as many as possible. And obviously you can ask your questions offline on Slack channels and other forums after this Q&A. So Jacob asks, can Linkerd be used to separate namespaces so pods in one namespace cannot access pods in another namespace?
Currently, no. But that is an interesting feature request, and you're not the first to ask for it. Right now, the behavior, the kind of starting point for us is we don't want to break anything by default. So we try to proxy everything as hard as we can, but adding that kind of policy around like this is allowed and this is not allowed is definitely on the roadmap. So I would encourage you to file a GitHub issue on the Linkerd 2 repo in the Linkerd GitHub project and tell us exactly what you want.
Fantastic, thank you. Ronan asked, does the Linkerd tap only support gRPC?
No, it supports HTTP just as easily. And then right now it is just on the headers, so you don't get the request body. What is definitely coming up soon, because I think this is a super important feature, is the request body as well. And of course, there's that when you combine that with TLS everywhere becomes really, really interesting, because now TCP is not going to help you at all. Not that it's even easy to do it in the first place in the Kubernetes cluster, but once you have TLS, now you're totally SOL. So yeah, once we get request bodies through there, it's going to be even more powerful. But right now, yeah, HTTP works just as well.
Thank you. I think we have a question from Saeed, who asks, what is the point of gRPC if you're using Linkerd? Which I think that's a nice existential question.
Well, I don't know what's the point of anything. So I mean, that's a good question. This is probably more a question of gRPC than anything else. I think what gRPC gives you, and I'm like a 10% expert on this, is two things. One of which Ben touched on, which is, okay, you now have using protobufs rather than kind of JSON, whatever, which means you're kind of forced to standardize. Like you have this formal, like, here is the API, here's the request that I expect, and here's the response that I expect. You get some type checking and stuff like that in the in the code. That's really helpful. It also reduces the serialization and deserialization costs dramatically over something like JSON. And then finally, I think the other benefit is because gRPC is built on HTTP2, and this is kind of where Linkerd starts coming in. Because it's built on HTTP2, you end up with dramatically lower TCP overhead because H2 is really good at keeping one connection open between any two pods. You don't have to have 12 connections or 50 and multiplexing requests across that. That can really reduce your tail latencies, especially when you combine it with things like negative acknowledgement. Like you can say like, hey, I don't want this request right now. But the implication, like kind of the side effect, is that layer 3, layer 4 load balancing, which is done at the connection level, starts breaking down. So because you just maintain this one connection open all the time. And we have a blog post coming out about this pretty soon. But one of the biggest drivers, and this might have been a driver for Ben as well, maybe you have a comment, Ben, for early Linkerd adopters was, I need to load balance gRPC calls on Kubernetes.
Yeah, it was definitely not our minds when we picked it. Like it helps us out so much for just being able to scale out horizontally with all the pods that are running. Yeah, it's good.
Okay, I'm going to summarize 3 or 4 questions in the same vein here. Traffic routing features like Canary, A/B testing, circuit breaker. Does Linkerd provide any of these?
100% on the roadmap. We wanted to, we know we have to do that stuff. What we wanted to do first was get telemetry like totally nailed down. And then from there, get on some of the reliability features like retries and circuit breaking and stuff like that. And then after that, we'll probably add routing. I think for us, our experience with Linkerd 1.x, so 1.x, supports everything. In fact, 1.x has this very powerful, complicated language called dtabs. It's like this backtracking, hierarchical, kind of mapping of, concrete name to semantic name and like all this stuff. It's very, very powerful. You can do all sorts of crazy routing stuff, but it's really difficult to understand. And we had to build all these tools for how you, express that and how you understand what your dtab is doing. So the one thing that we don't want to do is like repeat that experience where you have all this power, but it's incredibly hard to understand what's going on. So that's all to say, I would love to, again, see a GitHub issue from you or from all of you saying exactly what you want from the routing layer. Is it blue-green deploys? Is it canaries? Is it, how does it compare to, you can do blue-green today with Kubernetes by doing label flipping. Why is that not sufficient for your purposes? The more of that kind of input that we have, the easier it's going to be for us to make a solution that's actually useful to people and not overly complicated.
Fantastic. There was an interesting one from Ronan. Ben, you mentioned that you can see the relationship between the services. Can you show an example of this? Does it draw a pretty picture?
Do you want to show the dashboard again, William?
Yeah, let me load it up. We kind of saw that in, let's see, is it still up? I killed that entire namespace. Maybe the entire namespace.
There was a blog post in the chat we could probably repost and folks could see that, but you do get a graph of relationship between your services.
Yeah, you get incoming and outgoing services for one service. I think there used to be the ability to see everything that's connected to everything at all times, but that gets very messy very quickly, especially when we've got something like GraphQL. Like that's very big to show on one page. I do know there's a good tool to do this, which is built like Weave, I think, isn't it? The Weave open source stuff. If you want something like that, that's probably a better solution. Yeah,
so we actually have gone back and forth on this a bit because we did have a full topology, like boxes and arrows graph that was drawn, and I think it's still in there somewhere. Those graphs are awesome for demos, but as soon as you have 40 services, it just looks like a mess. So what we've done, and what you kind of saw in the demo, was if you're looking at an individual service, we'll show you all the incoming connections and we'll show you all the outgoing connections, right, on a per service basis. So we give you this little slice. We call it the Octopus graph. It's like there's, here's your service in the middle and here's the arms on both sides. And that's been the most kind of sane view we've come up with. One thing that we've done, which has been a little difficult, is we wanted to draw that entirely based on metrics data without requiring tracing, which has been a little a little tough, but we're now at the point where if you're looking at a single service, you can definitely see incoming and outgoing connections on a per service basis.
Okay, this is also 3 or 4 folks have asked, does Linkerd 2 support tracing, open tracing, or plugin to have any tracing support, I guess is the overarching question.
Yeah, well, I feel like I'm repeating myself. Yes, it's on the roadmap. No, we don't have it right now. And that's an easy one. Like, we should just add it in there. Yeah, you know, make an issue, submit a PR.
Fantastic, thank you.
Yeah.
So,
like I said, 1.x had Zipkin, and like it was really, really useful for a lot of folks. And
right.
So it's just, you know, on the list of things we gotta add.
Okay. There were some data planey style questions in here I was going to take a stab at. Are there any plans to use BPF in Linkerd, like psyllium?
You know, I'm probably not the right person to ask. There's nothing that's super top of mind, that's super high priority for us. Like, no one has really asked us for that yet. If someone did, like, I guess we would take a look. You know, why not? I think my sense is most of the users that we've seen for whom Linkerd has been valuable don't have the kind of incredibly high volumes of network traffic that BPF would make useful. It's, you know, most of our adopters have been folks like Ben, who handles a high volume of traffic with his wildly popular app, but doesn't need to, like, you know, stream video or whatever. So no immediate plans, but if that's something that's really interesting to you, you know, we're certainly open to it.
Okay, one final question here before we round this out. There were quite a few questions about how does Linkerd differ from Istio and service meshes? So do you want to take a stab at that?
That's always the question that I'm dreading. So yeah, no. So, you know, the goals of the 2 projects are pretty different. In a lot of ways, Linkerd 1.x is pretty similar to, or Istio is pretty similar to Linkerd 1.x. You know, and the goal is we want to give you every possible feature that you could ever imagine, and to us, it doesn't matter what the complexity is. At least this is my. I don't want to speak for the Istio team, right? But this is my impression, is that for them, the cost of complexity is not that bad. It's more important to have a huge feature set. For Linkerd, the focus, you know, certainly with 2.0 is very different, right? Where we really care heavily about the cost, about the complexity, you know, at the expense of it not having 1,000 different features. So I think the 2 are going to end up kind of in very different places. And I think which one is right for you really depends on, you know, whether you care more about having the set of features or whether you care more about the kind of conceptual and operational complexity. That's my impression. I think they're both awesome projects.
Alrighty, that's all the questions that we have time for, and thank you very much for all the attendees that asked questions. I think we had a total of 23. We made it through 15. If there are any that I left dangling or we didn't get time to answer, I urge you to go over to the Slack channel and ask them, or any other open forums to ask those questions. It's up there on the slide that William has. But thank you very much, William and Ben. Thanks for everybody for joining us today. This webinar recording and the slides will be online later today, and we look forward to seeing you at a future CNCF webinar. Have a great day.